All right, so in the previous video, we talked about the properties of logarithmic expressions and how to expand, and also look at how to condense. So let's look at some examples. We have here, it says, use properties of logarithms to expand the logarithmic expression as much as possible. Where possible, evaluate the logarithmic expressions. Okay, so we have log base 4 of 7 times 2. When there is a product, or when it's a product, what are we to do? What does the rule state? That we're going to add the logarithms. So let's write it out. We're saying log base 4 of 7 plus log base 4 of 2. All right, so now let's look at the next example. We have here log base 11 of 11x, and then we're going to look at log base 12 of 12 over y. So we have here again, we have a product. So what we're going to do, let's put the times here, product, meaning we're going to add the logarithms. So we have log base 11 of 11 plus log base 11 of x. Now I want you to recall a property, because the instructions here says, where possible, evaluate the logarithmic expressions. And I want you to recall that whenever we have a base, log base 11, and that of part where it's the same, this is our of part, when those are identical, it's going to equal to 1. So here's the property itself. Log base b of b is equal to 1. When those two are the same, you have that logarithmic property of 1. So this log base 11 of 11, that gives us 1 plus, and then bring down the log base 11 of x. There we go. Now the next one here, log base 12 of 12 over y. So this is division. This is a quotient, meaning we're going to subtract the logs. So let's go ahead and write this out with the subtraction between the two logs. So we have here log base 12 of 12 minus log base 12 of y. And here again, that same property, okay, log base b of b is 1. Well, log base 12 of 12 is going to give us 1. And then bring down the minus log base 12 of y. Okay, let's look at some more examples. Okay, so here we have log base 2 of 16 over y, similar to the last uh, example where we have a quotient, meaning we're going to subtract the logs as we expand this out. We have log base 2 of 16 minus log base 2 of y. Now, let's look at this log base 2 of 16. Okay. If I ask you, can that be simplified? We will say, or you will say yes. Let's write this log base 2 of 16. Let's write this as an equation where we're going to let it equal to x. And we want to fill in that part. So we're going to convert this log base 2 of 16 equals to x in exponential form. So we have 2 to the x power is equal to 16. Well, what will be x? X will be 4. Okay? Therefore, log base 2 of 16, that's going to be 4. And then we have minus log base 2 of y. Next example. We have ln of e to the 7th over 9. Quotient again, we're going to subtract. So we have ln, our natural log, of e to the 7th minus ln of 9. Now, for the ln of e to the 7th power, recall that ln of e to the x power is going to be x. Okay, so when we have ln of e, and I want you to see this, I'm going to bring up the graphing calculator for a second. And let's cut it on. Let's clear it. So here's your ln button. Okay, so if I just only wanted to focus on just ln of e, remember that ln of e is 1, and 1 to the 7th would be, excuse me, ln of e to the first power. Let's look at that. Let's do second and ln to the first. Okay, let's delete that and then press enter. It's going to give us 1. So anytime we have a power, ln of e raised to a power is going to equal to that power. Okay, so if we put in ln of e to the 7th power, is going to equal to 7. And there we go. So we have here 7 minus ln of 9. So when we have the natural log e raised to the power, it's going to be that power. Here we go. So here we have log base d as in dog of x cubed. And then we have ln of the cube root of, ln of the cube root of x. Okay, so here we have a base raised to a power. We're going to use that power rule, okay, where we're going to bring down the 3 and write it in front of the log. So we write this as 3 times log base d as in dog of x. Okay, so we're using the power rule. Okay, next example, ln of the cube root of x. Let's rewrite this cube root of x as an exponent. So we have here ln of x to the 1/3 power. And because we have a base raised to a power, we're going to use the power rule again, where we're going to take the 1/3, write it in front of the ln. So we have here 1/3 ln of x. And there we go.